Well, welcome everyone. We appreciate you coming out, especially with the weather tonight. We do have a great lineup of demos, some pretty cool startups. I'm Artie Merritt, the PD go-to-market specialist for Agent Core here on the West Coast, working with John, my teammate, the SA specialist.
So, hi everyone.
Oh, cool. How many folks are familiar with Agent Core? Anyone play around with it? We have a few. We're going to provide a quick overview, little demo on that. Are folks using Bedrock at all? Anyone familiar with Bedrock? Cool. So Bedrock is our managed service for Gen AI. It's one way to access models. And with some of the benefits of it, it was the model choice. We have over 200 models available. But more importantly, we're not using the data, the underlying model providers aren't using the data, so you have peace of mind on the data privacy and data rights. And then with Agent Core, this is our new set of components that make it easier to build, deploy, maintain agentic AI solutions. So hand that over to Jean, and then we'll get out into the demos.
All right. So I'm going to do a bit of a demonstration of how to start deploying Agent Core. If you have questions around what Agent Core is, what it does, how to use it, all of that, you're welcome to find me at the end of the presentation right at every start. But we just released a brand new CLI for our Agent Core service. I wanted to show you what it does. So here, to give you an idea, I just installed my Agent Core CLI, and my objective is to develop an agent that is going to be doing something useful. So the first thing I need to do is do an Agent Core create. And my Agent Core create is going to create all the scaffolding for my agent to be created and tested locally. So I have a bunch of decisions to make. My project is going to be something like, yes, I want to add an agent. My agent is going to be super awesome agent. And I want to create a new agent. So I like Python and I like Strands. I don't know if you know about Strands. How many of you have heard of Strands before? 1, 2, 3, 4. That's not bad. So Strands is an open source free framework for defining agents. You can use it with AWS, you can use it with whatever you want on the backend, but really it's our opinionated way of how you can orchestrate multi-turn conversations with a foundation model. So here I'm going to use Strands as the way to orchestrate my agents, and I'm going to use Bedrock as the inference platform. But as you can see, if you want to use it with Anthropic directly, with OpenAI, or with Gemini, you can actually use it with any platform that can do foundation models, and that works with the framework that you've decided to use. So here, I also want to make sure that my agent has both long-term and short-term memory. So Agent Core is going to manage all of that for me, but I don't want to do all of that on my own. Cool. Now I'm asking Agent Core CLI to create my agent. That's all I needed to do so far. You may have noticed that I haven't told it what to do with the agent. So it's going to give me basically a basic prompt. And I can go and change my prompt. I can go and select another model. I can do all of that in the code itself. So it's going to be super simple. But really it creates all of the things that allow my agent to exist. First locally, and then in the cloud. And then Agent Core is going to take care of everything around, giving me an invocation API, and making sure that I can scale my agents and have multiple sessions for all of my users, going to thousands of sessions at the same time, while maintaining all of the isolation. Cool, I'm done here. So I can go into my super agent, so demo. I hadn't seen that I had called it demo byte. That's very, very good of me. So here, I'm going to do an Agent Core invoke. And I want that to be, first I want to do dev. So I want to test it locally. So here my agent is going to run directly on my laptop. So I don't know if you can see that really, but here I can interact with my agent and it's running it locally. So if I want to do changes into my code, I can do all of my tests here before I deploy to the cloud. So here if I ask it a question, where can I find good in San Francisco? If you don't know what that is, please look it up. It's fantastic. I switched from Brittany, which is a part of France. and San Francisco needs to know I know. And basically, it's interacting with me. I already have a first agent that can do multiple turns to a model, and that can use tools, which is super cool. Now, I want to have that, and I want to do a small modification to it. So here, I can do into, I can use, I'm going to use Kiro's here. Like, how many of you know about Kiro? Oh, cool. More people know about Kiro than Strand. So Kiro is our agentic development platform. If you've heard about Cloud Code, it's a very, very close friend of Cloud Code. It does basically the same things here. So here I'm in my environment. I can tell it, hey, modify my agent so that it answers with rights, which is always something that you want to do with your agent. And so my Kiro is just going to do the modification of my code, and then I'm going to deploy it to the cloud. So here, so the cool thing about Kiro, by the way, is you can use Anthropic models on the back end, you can use open source models on the back end, you can use a bunch of things on the back end, and it's a fully managed service and works really well. So here, I'm happy with the change it has made. You can see that now your responses should be poetic and fun. Okay, cool. I'm going to kill Kiro, and I'm going to do an agent core deploy. All right, here it's making sure that my project is okay, that everything is as it should be, and then it's going to deploy it directly onto my AWS account. It uses CDK by default, but it works really well as well with Terraform if you prefer Terraform, and it's going to deploy my agent core runtime. It's going to deploy my memory so that I can maintain my sessions. It's going to do all of that through infrastructure as code so that I can have versions and I can deploy everything and maintain everything. And then I'm going to chat with it again. And as you can see, it takes only a few minutes to get started. So if you have an idea of an agent and if you want to be able to deploy it in a way that maintains your governance, your security, and allows you to scale to whatever your startup needs to scale to, that's a fantastic point to get started with. And it's also agnostic. If you want to use LangGraph, use LangGraph. It works with LangGraph. If you want to use LangChain, use LangChain. It works with LangChain. If you want to use OpenAI or Gemini as a backend for your agents, you can. It's absolutely fine. We're just going to take care of making sure that all of your agent invocations scale to the best of our ability. All right, it's currently creating all the resources that I don't want to have to create on my own, but basically it creates the identity and access management roles that allow my agent to do things. It creates all of the permissions, all of the, what I called scaffolding before, but basically all of that you need for your agent to run, we do all of that for you. And I have 3 minutes. I'm betting that I can get that deployed and tested in 3 minutes. If I don't, we'll give you a QR code that gives you AWS credits. Does anyone have any questions on Agent Core, what it does, the CLI? Where am I deploying it? I'm deploying it in my AWS account, so I can show you that. Here, so if I go to Bedrock, I'm using my my credentials on my session to deploy to my AWS account. So if I go here in Agent Core, and if I go to runtime, you can see that I have in Agent Core memory something called demobytes, because again, my typo from earlier today, that is currently creating. So what it's creating right now is my short-term and my long-term memory. Agent Core manages that for you. Usually your agents need two things. They need to be able to remember what you said just before, and they need also to remember significant things from what happened in other sessions, like your user preferences, like summarization of what's happening on other discussions with your user, or potentially things like episodic memory, but being able to remember how to solve for a specific problem. Well, what we do is we actually extract that automatically from your short-term memory. So your agent gets the best of both worlds, remembering what just happened and also remembering things that are valuable from previous conversations. And as soon as this is done creating and it creates my runtime, I'm going to be able to interact with it. As you can see, we have a bunch more things in Agent Core. So we have the ability to host your MCP servers without you having to manage your servers. We have the ability to define policies of what agents are allowed or not allowed to do. We have the ability to manage the identity, so basically who can call your agents, what your agents can call on behalf of your users, which is hard. I don't know if you've tried to do that already, but it is a big tough problem to solve. I'm not saying we solve it, but we make it a lot easier for you to solve it. And we also have two things that might be interesting to call out. We have a managed browser. So if you're doing something like QA, or if you're asking your agents to interact with something that is not meant for an agent to interact with, we have a fully managed solution that allows basically to have a Chrome that's managed by a model. We allow for browser use or for Nova Pact. I'm going to ask that question again. How many of you have heard about Nova Pact? One, that's cool. So Nova Pact is both a foundation model and an API that allows you to pilot a browser. And we offer that within the family of foundation models that Amazon creates, which is called Nova. So if you're interested, there is. You can test it out at nova.amazon.com. It is right here. And here you can test it, it's a sandbox here. But if you deploy it and if you try it through Agent Core, you can actually have it do actual production tasks. But yeah, I recommend testing it out. It's a fantastic way to have your agents interact with what is meant for end users. And I'm out of time, but I'm still going to do an Agent Core invoke. Here, as you can see, I'm interacting with my agent that is in US East 1 in our region. So I can ask it questions. Where is Paris? And this time, I'm not doing the inference request from my laptop. I'm invoking the agent. The agent is in Agent Core. It's doing the inference request to Amazon Bedrock, and it can scale as much as I want it to do. And that's the demo.
Awesome. So Jean, myself, I think there might be some other AWS folks floating around. So definitely come up and ask us if you have questions about any of this stuff. First up, we have Sharon with Cleric. Yeah.
Okay, everybody hear me? Right. Wait. Yeah, okay, cool. Alright, hey everybody, I'm from Cleric, and we're building an AI SRE. This is the only diagram I'll show you, I promise. That's going to be a demo, and then try to whiz through quickly so we can do questions. How many of you are not using coding agents? Okay, so most of you are. Great. So you're obviously very familiar with the inner loop, right? You use a coding agent, you ship features very quickly. So to us, like what's interesting is what happens after that. Like at CI/CD, things fail. How do you act on it quickly? Eventually, prod is actually the most expensive feedback loop, right? Like you can go very fast in your internal dev, But you make a mistake in prod, maybe you realize a week later, 2 weeks later. And so to us, our thing is that an AI SRE is the expert in production, not your code base as a coding agent. So I'll show you like how we think about it and what it means. The main thing which I wanted to talk about is that, at least like for these demos, I wanted to focus on like what is the actual problem in production. So I'll show you some relatively simple ones, and then at the end I'll show you how we actually use it, because production is always more messy. So before I start, I'll just trigger a few alerts here just to show you how it looks like live. I'll ask a question from Cleric, like, hey Cleric, can you check the Bedrock stats? So we run on Bedrock and tell me if there are any latency spikes. So we'll get these to run in a little bit, but what this looks like, right, is that in a typical alerts channel, you get alerts falling, right, and people are sometimes asking you questions. And so when I have an error like this, like user unable to log in, auth request returning 513, it's like a very demo-y alert, but you can see that you have an agent that's actually able to jump on and do the job of like what an on-call person is doing, except it's going to be at 2 a.m., 3 a.m., doesn't really matter, it's going to jump on it and go figure out like what happened. So in this case, we have a very cryptic message. Cleric goes in and says, okay, like this is the issue, there's a typo in the application code, like in reality this should never get to a CI, but here's what happened, why it's happening, and then it also gives you some suggestions on what you can do if you want more information. What's interesting is we can actually look at it, how it looks in the UI. So you can see it did something like 18 rule calls. So let me just go. It went to like multiple Kubernetes clusters, it listed all the resources, looked at the pods, looked at the code, just like went all the way through, and then finally it realized, okay, I think I know what's wrong, here's the issue. And from a setup point of view, it's very easy. So we've done something where you just have to go to integrations, and a little bit like how you set up a cloud code or something like that internally, you're just really setting up like read-only integrations, like AWS. So we'll generate a trust policy for you. You just have to create it. Kubernetes, Grafana. So the big deal with SRE agents is that you want to have as much access as possible because the problem could be anywhere, right? So let's now look at what happened in the latest one, right? So what I just showed you is this one, and you can see it did 18 rule calls, and this is the first one I ran, right? If I look at the one that happened, like now it's actually running, right? Should I do the one that happened here? So there's a feature which we have where if you do have an alert storm, it already tells you I'm looking at it. It's smart enough not to just repeat the same thing again. I'll show you this one that I ran earlier. Let me just see. So, okay, this one I think is just finished. Let me just run this again because it was already investigating it, so it felt like it's already doing it. Yeah, so this is actually investigating. Okay, so while it's doing that, I'll show you something a little bit more interesting. So here, if we go and look at it right after I ran it, like a second time, the first thing that we want to do with learning is that you'll see that it recognized that it was actually something, it's a non-issue. I don't know if you see that. And so this is to me what agent learning looks like. Like every time an issue is happening, if you think about like from a human perspective, each person is learning just on their own. But now the agent's learning across every alert in the entire company, and it's able to come up and pick this up, and it can actually like reference the previous issue. It will cite like Kubernetes resources, things like that. So to us, the agent in production is actually the less interesting piece. The more interesting piece is like the organizational memory that's gathering, right? So the people in the services team or payments team doing their investigations should improve the agent for people in the database team, because then those investigations can actually work with each other. Another like very concrete example I can show you is that you can see here it only did 9 rule calls. So this is again like from the agent point of view, it's much easier. I'll show you the original investigation, which we did here. you'll see it did 18. So it's a lot slower. So the idea is that at the first time it's okay to take your time to get it right. But then as you're learning more and more, you should get faster and faster and obviously they're a lot more accurate. Other stuff that you can do are things like when you are interacting with it, it should also just learn from you. So in this case, like it came up and said, okay, like here's what happened. And I said, hey, by the way, this is in the scenarios cluster. You can make it a little bit more advanced. And then it responds and also offers to remember it the next time. You can also ask it specifically to remember something. So, in my Bedrock query, I'll show you the one I did recently here. Yeah, so this one is interesting. I asked it for the Bedrock stats of the last hour, and then I said, remember that I only care about Opus 4.6, 4.5. It says, okay, I'll remember that for next time. And then, okay, here's what happened with Opus 4.6, 4.5, and I'm not showing you any other details. So there's something I ran a little bit earlier. So we should see it in what I just asked. So here, you can see it has remembered it. So I asked it just now, like 5 minutes ago, and it remembered what I said. And it's only giving me stats for 4.5, 4.6. Same thing, like, with this incident, it will tell you that it's a non-recurring issue. Something I think a little bit more interesting is like what this looks like in real life. So if I go to here, so real life is very messy. So here's like a real example that we had like yesterday. So we had a monitor that was alerting for our software compliance. And all our PM did is just do a screenshot and say, hey, we got this issue. What's up? Like, what should I do? So it goes through, and you can see this is sort of where an SRE agent comes like in handy. It's going through everything. It's looking at our code, looking at Terraform, looking at AWS, looking at everything, and saying, okay, here's what happened, and then we have a discussion. I'll stop here. Maybe just one other example. Here's an alert, resolve it, and then our engineer says, okay, we'll create a linear card and work on it. So the idea is that it's just like doing investigations for you all the time, and you can basically just get back to coding, which is what I think we all want to do. I'll stop here and let me know if you have questions.
Anyone have any questions for Sean?
Yeah. Yes. Yeah. So as long as you connect it by MCP, we can read anything and write to it.
What are the biggest security challenges you have when you are granting so much access throughout the entire production environment?
So the big thing is we don't allow write access. So if you accidentally gave us write access to anything in prod, the agent would not use that token. Because that's, I think, the most risky, where the agent just does something you don't expect. From a security point of view, like there's also like pretty basic stuff that we do where we firewall the agent. So for instance, when you use Cloud Code, it has world access to the internet to go pull stuff. We don't allow Cloud to do that. Because you could poison, like have something online to say, get these credentials. So we only allow Cleric to access just your infra, nothing else.
Thank you.
Sure.
Well, let's give Sharma a round of applause. So next up we have a Geo with Fire Tiger, which is a pretty cool name.
Like it. Okay.
That's good. Starting now.
Hi everyone. So my name is Ashil. I'm the co-founder of FireTiger. You can find me online on GitHub or the LinkedIn related to it. Big user of coding agents, as you can see by the intensity of the code production that's happening over the last 6 months. And I'm gonna try to do a live demo. It's very exciting for me to be here today because we're actually launching our product publicly tomorrow. So thank you so much for having us tonight. This is like the best time possible. So what we're gonna see here is kind of like preview of what everybody's gonna have access to tomorrow. We'll appreciate a lot of support on social media if you wanna relay the message and carry our voice. And so what FireTiger is a autonomous set of agents that operate your systems in production. So we're thinking of it as coding agents produce all the code that we ship now. And it doesn't make sense to ask people to operate this code, right? Like we're not the assistants of those agents, right? They should be the other way around. And so we think that we can bring a product to market that solve these problems and kind of like close the loop on the software lifecycle. So the demo I'm going to show you today, I put together this little like demo website, and it's just like a little catalog of authors. Claude like completely psyched up this thing. I'm not really sure how it works or what's in it, but. What I know though is that the page load is pretty slow. Like it has this little indicator at the bottom. It's like 1 second, sometimes 2 seconds, sometimes 3 seconds. It's just like, it doesn't do much. So like, why, right? And I want my users to be happy, so I want to give them a good experience. So I use FireTiger for this. I'll zoom in a little bit. So in FireTiger, I created a couple of connections, and I got my Superbus backend available for the agents to connect to and explore. I got my GitHub account also, where my website source code is hosted. And I've got some data lake where I'm piping the logs from Vercel, where I deployed the site. And so as I'm refreshing it, logs get generated on the backend and then pushed to FireTiger and recorded in this data lake. And so what I want to do is ask, all right, my website is slow. Let me give it the URL so it knows what I'm talking about. So here I'm launching an agent online. So it's running in the background. It's going to start doing a couple of things, loading context, accessing the state of connections that I have set up, and then try to start getting work done. And I understand what is the reason why this website is slow. So it's running on AWS Bedrock in the backend using Sonnet 4.5. I think 4.6 just came out today, so probably gonna try it out. And now it's just exploring what's going on. So it wants to check out the traces, kind of psyched up a SQL query that apparently had an error in it. It's like, oh, I don't know those schemas, so I'm gonna go and discover what tables are available and what schema do they have, so they can start exploring the data a little better, right? Third time's a charm. Now it actually access the traces. And so it's doing this exploration. This is the first time it runs, so it doesn't have a lot of context. But over time, as it builds up knowledge about my system, my product, it's going to start, gathering context that helps it be a lot more effective in the number of iterations that it has to go through to understand a given problem. In the demo that I did earlier, it went faster than apparently this time. Oh, look at this. So now it's using the bash tool as well, apparently. It's doing some slicing and dicing of the data that is loaded in context. And something I can tell also about this is I'm really excited about Agent Core. I've been looking into the tech a bit. We're actually not running on Agent Core because our infrastructure predates its release. But the way all of this works is just a keeping all the session state on S3 and using the object store notification as a way to invoke Lambda functions to do state transition. So you can think of it every time there is an update to the session, so a message is published or the LLM produces some output, we record this on S3 and then it kind of like triggers another Lambda to run and process the next step. So it's got this like distributed state machine, completely cloud native, with just S3 Lambda as the primitives. Right. So it looks like it's starting to like make sense of what's happening. It's saying analyzing head request pattern, and it's giving me a conclusion of what is going on. And so pattern, we'll go quickly. 50 plus variable head request, blah blah to pseudo base. Okay, I don't know what's going on here. Instead of head request, use preferred contact. Exactly. I'm not smart enough here, but I have my test run where the output was a little bit better. So obviously the other agents, right? Like they're a little bit random. I could continue and like ask it to refine here, but for the sake of time, I'm just going to show the previous investigation that I ran on the same problem. And in this report, it gave a better result on first try, where it actually went and like explored the code base, correlated it with the logs, and then identified what's going on here. So it's telling me I've got some kind of like loop that's doing select over and over. And if you've ever selected data on a database, this is not the way you do it, right? You just do a select, and then you put some filter or you express this in a single query instead of selecting every single item. So this is kind of like an overview of how it works. However, here we're just really in investigation, right? Like I came with a problem, I had this one-off thing that I want to investigate, and I'm kind of like using the agent to help me with it. But really where FireTrigger we think is going to shine is like the ability to task agents that are just going to start doing work for us in the background, like 24/7. So I could go and create an agent and say, okay, actually I never want my website to be slow. So do whatever it takes, but if you detect page load slowness, you investigate, you identify the root cause, you open a pull request, you apply a new index on the database, basically like whatever I want to task the agent with that I would do myself, we can do it online with FireTrigger. So I'm going to stop the demo here. Maybe there's some questions.
Any questions for Mitchell? You were showing earlier the SQL. How does it have access to that from the database? The database SQL from the website? Or was that your own?
So here,
Yeah.
this is a SQL query that's just like generated on the fly by the agent to explore the data set that contains the logs from your cell. So it just, as I would do it myself as an engineer going and exploring the data, the agent is basically doing this work.
Anyone have any questions? How do you price it? How do you price it?
Price it, first plan is $600 a month, and then it goes up. And for large enterprise that are concerned with data access, we do bring our own cloud.
Cool. All right, well, let's give a round of applause. So next up we have the folks from Grafana.
Hello. While he's setting that up, I'll steal a minute if it doesn't count against the 10. Introduce ourselves. So Grafana is a full stack observability solution. We have Gen AI capabilities built into our observability solution. My colleague David will be demoing that in a minute here. First, I want to mention why we migrated recently to Bedrock. Portability, Bedrock offers, so we're able to switch out LLM models easily for specific use cases that they might perform better against. Performance, obviously AWS provides pretty good infrastructure and a lot of compute when we need it. And we're an ISV, so we have a PPA with AWS, so all the spend goes against our PPA, which AWS gives us a lot of benefits as part of that multi-year agreement. So those were some of kind of the business reasons that we migrated over to Bedrock recently. But now more about demoing the actual features.
Thanks. Yeah. Hey everyone, my name is David. I'm a solutions engineer at Grafana Labs, and today I'll be going through some stuff around AI for better observability. I have 2 slides, 1 demo, and it looks like 9 minutes and 11 seconds to do it. So let's dive in. I wanted to start with a sort of paradigm that everyone may be familiar with. So the capabilities I'm going to be going through in Grafana Cloud kind of fit into these like tiers or buckets, if you will. So if we take a look here, there's sort of this chatbot-like interface. There's the LLM that can kind of summarize what's going on, but can't really do anything on your behalf, right? You move up the stack though, you get something a little bit closer to Cursor with being able to maybe take actions on your behalf or help improve your reliability as opposed to just summarize what the current state is. And then there's what I like to think is the holy grail of observability, which is you fix my problems without me knowing about them kind of on my behalf, right? And that's sort of, I think, where the industry at large is trending. So we'll be diving into what the kind of offerings that Grafana Cloud has with respect to that. I certainly won't claim that we're at the level where we're just going to fix all of your problems without you knowing, but it's I think certainly trending closer to that than we've ever been as an industry before. But those are my 2 slides. Let's go ahead and hop into the demo. So raise a hand. Who's used Grafana before? Yeah, you. So yeah, this is our managed service in the cloud. So it's a SaaS product, but this is something that we debuted earlier this year. I'm going to prompt it a few times so we can get some stuff going here. So I'm going to follow that sort of paradigm where it's the summarize something for me. So what I'm asking the Grafana assistant to do here is say, build me a service diagram that shows me kind of all the services in my environment. I want to understand what services interact with what, and from that maybe infer some certain connections or just better understand my system, right? So what it's doing here is it's looking at the infrastructure memory that's built from all the telemetry, the metrics, the logs, the traces that are being sent into Grafana Cloud. So long filibustering for the machine, we can see that it spits out a mermaid diagram here, and we sort of see like, maybe this service interacts with that. I think the key unlock here is that this is something that I have no doubt all of you, especially the ones that are, programming on a day-to-day basis, working on your individual microservices or what have you, you could do this, no doubt. I think it's a time savings thing, right? This would take me maybe to build like a better part of 2 hours or so, right? Especially if I want to make it good. And then instantly it becomes irrelevant. It's outdated after you push one change, right? So it's sort of the time savings thing, right? It not only gives us that mermaid diagram, but also we see here the maybe a textual format, just telling us what our critical user flows are, right? This is the checkout flow. This is how I process transactions. And you can kind of imagine, what this might unlock for you, right? You have someone new, like you all are growing companies, you bring someone new on and maybe you need to get them up to speed, and that can be difficult. But if you, have this, maybe you can get them up to speed that much quicker. So that's the sort of like summarization. Right? This is cool, but it's not really doing anything to make my observability better, so to speak. So if we take a look here at my second prompt. Let's try something else. Let's say instead of just summarizing passively, kind of just like reading back my telemetry after I ask for it in natural language for something, what if I actually wanted to investigate? So here I've asked the Grafana assistant to investigate an issue with the product catalog services. Is going to be very similar to like the Fire Tiger, the Cleric, these sorts of things, right? It's I have some telemetry I'd like you to investigate. Where this is going to sort of depart, and I'll just pick a one of random paths, so we don't have to wait for it to finish. What I'm able to do with that from a sort of active implementation. I want to make my observability better. Here we have a kind of investigation at Grand, said, these are some possible things that you might want to look at. If we wanted to continue this conversation, we would be able to here. So I have all the context from that previous conversation. Now I would like you to do something for Grafana Assistant to actually make my observability better. So what I have here is something saying, hey, let's create an alert. So the next time this issue happens, we catch it, right? Like I think the cardinal sin, for my opinion, in observability is you have an issue, it's causing you some problem, and you don't do something to fix it, right? You don't write your post-incident report. And I think when you're moving at startup speed, it's difficult to do that. So I think, again, this is not something that you couldn't do on your own. It's just a matter of could you do it a little bit faster and save yourself that time. I think the less time you can spend doing ES, the more time you can spend doing the things that actually move the needle. So here you can see, this is guiding me and telling me how to create this Grafana alert rule. I'll admit, I think a lot of my work is sort of driven through this these days, right? I like it as a cursor and producing lines of code as it is to using the Grafana assistant and producing good observability outcomes, right? I don't really know how to create a Grafana dashboard all that well. I don't know how to create a Grafana alert all that well, but I can use this to sort of guide me along the way. So we're moving our way up the stack. We summarized, we created. Now, like in the ideal state, we'd like for it to kind of produce a reasonable root cause analysis, maybe get us on the right path. So for that, we have this concept of Grafana investigations. Very similar paradigm, right? It's we're using, instead of maybe one agent, like everything we've looked at so far is single agent. You're making one call to Anthropic, say API or wherever it might be, and then going from there. This is a more coordinated effort. It's done in parallel. We want one agent sort of leading all the other subcontractors to go ahead and fix all of the different things that are wrong with our house. So we have an agent that's really good at solving Prometheus problems, one that's good at querying Loki for our logs, or Tempo, or Periscope for our traces and profiles, respectively. And what's nice here is we get some kind of pretty in-depth findings here, right? You remember when we saw the Grafana Assistant version, just the chatbot interface, it was sort of, hey, like we think this might be the issue, this might be the issue. This here is linking out to all the possible things that might be, and we can see, the true view, how the agent itself actually went and made that investigation, as well as a timeline, right? So you might be asking, like, hey, like, when might I use this? I think my encouragement to you all is not to use this as a crutch expecting the answer, but my vision for this personally, and where I see my customers have the most success, is your Sev 1 or Sev 0 alert fires. If this can be kicked off by a webhook or an alert firing, so that by the time this 5 to 10 minute investigation takes place, that's the amount of time it takes you to get off your bed at 3:05 a.m. to the desk, right, and to start troubleshooting. So this can give you a head start. Again, to repeat the theme that we've been kind of pulling through this entire time, not going to be something that you can't do yourself, just a little bit faster, a little bit more focused on the things that actually matter. So yeah, that's all I really had for that. It's got some time on the clock, so I guess one thing that Rob wanted to mention was this.
Who here works for a startup? Cool. So every week, if you want to scan that, we offer up to 100,000 Grafana credits for our solution for AWS partners and startups. We go through that once a week. It's not guaranteed, but I'd encourage you just to fill it out. It's 5 questions, 5 radio buttons, so it should take about 60 seconds. And if you do it, feel free. We have some Grafana t-shirts and water bottles. Just take one on your way out. I'll trust you. But yeah, you can then start exploring Grafana's observability solution and fully accessing some of these Gen AI features that David presented today.
Yeah, final thing on that as well, I guess that there's a starter program. I'm a big advocate and fan of it. We also have a very generous forever free tier. So if you just want to like monitor your whole lab or whatever, that's something that's posted in the cloud. I think it's I'd say pretty generous in terms of like a forever free, no need to plug in a credit card tier. So I use it to monitor my health metrics. I have my Whoop in my Garmin, so I joke with people all the time. I observability on machines would work, but on myself at home. So yeah, cool. If there are any questions,
Anyone have any questions? Well, let's give a round of applause. So next up we have Phil with TCN, or the Contract Network. Yeah.
Okay, I'm Phil Richards, and I'm with the Contract Network. What we do at the Contract Network is we are specifically building out an AI-powered platform to help with clinical trial startup. So we're a little bit different than some of the other things that we've talked about today already. So I'm going to show you actually a product-level implementation of agents that are going out to do these things. And so what we're doing in the clinical trial space is we are, the first thing we started was helping out with administrativa of the study startup. Because, for those of you, many of you may not be in that space, right? So it can take anywhere from 90 to 180 days from the time that the drugs are developed to the times when they can actually start the clinical trials. And most of that is administrative time. That's working on contracts and budgets and lab manuals and those types of things. And so what we do is we help shorten that time. We started with contracts, and then now we're doing the full study startup administration capabilities. One of the interesting things about what we work on is, and I've made this joke before, but like when we work on this stuff, saying something is good enough is generally not good enough. In the work that we do, we have to be very precise, we have to be very complete, we have to be very accurate, and we have to follow instructions very precisely. So some of the things that you'll see with LLMs in general, we have to correct for some of those problems in our system, and I'll show you how some of that is done here. And so, you may ask yourselves, I think of like, there's maybe 3 reasons that maybe, what I talked about today might be interesting to all of you. First is this is actually an implementation. We're in production. People are using this. We're seeing the results in this. And so all of the headaches of going through the production deployment of agents we've done, we're working on, and we're dealing with every day. And what I'm going to show you here is all built on Agent Core. So the stuff that we saw in the very, very first description, so we're deploying agents on Agent Core, we're using the memory, we're using the sessions, we're using the gateways, the identity, and all of those things. And so if anybody has any questions about that stuff, I'm happy to help out with that too. And then the last thing that is, at least I think is kind of interesting as we talk about this is, a lot of times, there's a lot of discussion about the importance of AI and what it means for software development and what it means for SaaS companies and these types of things. And what I'd like to and again, we're not going to be able to talk about all this stuff, but I love it because what we're doing here with AI is we're literally helping save lives. Now, because every day that we can get like a clinical trial started earlier is a day more that we can help people with their quality of life and with their cures and those types of things. Now, granted, we're only working on the studies, we're working on the boring administrativa, but it's all the stuff that needs to be done as part of this, and so that's what we're working on, and that's the demo I'm going to show you today. So first let's start, we're going to create a new study. So a study is like a clinical trial study. I'm just going to put in a demo name here and start this off. There's a lot of information I can fill out, it's not all required. But the first thing that comes up, these are the workflows that we've built. Now these are all agentically driven workflows. Now these workflows, we've set it up in our system so that each one of our clients can use our default workflows, which are, I think, really great, because I worked on them. But they can also build their own workflows, and we can host them here as well. And so what you see here is what the clients have available to them. And each client can have a different set of workflows that are available. And each one of these can be a pretty complex workflow on the inside. Now, to do this, they have to upload their documents. They have to give the information for this that they need. So for example, the protocol here, I'm going to upload a protocol. And this is all publicly available data. and then I'm gonna upload a lab manual. Oops, that's the lab manual that I'm gonna put in there, and then put in the budget template here for this. So now we have the protocol. This is actually all the scientific information about what's happening. The lab manual is telling the labs how to actually do the clinical trial study, and then the budget for saying how do we do this. And then we kick it off. We can kick off these agents to go do the work, right? So success, it worked. That's part of the demo, so you get that success message. And so we track all of this, and it says, it's all in progress. People are, things are working. All the different workflows that we're doing. Now those documents that we uploaded, we put them all into pre-signed URLs, and so then when you start it, we actually copy it into the client's area. And we build a knowledge base using the Bedrock knowledge base capability to put those documents in a place where the chat and the other agents can actually interact with them. So really, again, if you folks haven't used the knowledge base, it's a really nice tool for quickly implementing the ability to do RAG or embeddings or that type of work. So now let me show you, like, each one of these individual workflows I can open up on its own. And so I'm going to open up our most complex workflow here. And before I open that up, I'm going to show you some of what it's doing just really quick. Like, this is an agent-to-agent workflow. So there's an agent at the top called the orchestrator, and it's calling a combiner agent that extracts timelines from the documents, activities. It does an enricher, budget extraction, map and gap. These are all the agents that are running inside of this, right? So now if I go here, and I'll pull up the one that's running right now. Let's go to the history. So you can see what I built here is we have this capability to show all of the actions of all of the agents on the workflow and what they're doing and the messages that they're providing. Again, generally most people aren't going to watch this because the people that I'm writing for, is, like some of the previous speakers who were up here, they're writing for technical audiences. This is a non-technical audience. These are people that may be technical in terms of statistics or in terms of science, but they're not technical in terms of coding and those types of things. But it's really nice and really helpful for us to be able to go in and say, here's all the agents, here's what they're doing, here's the messages. And if something ever, heaven forbid, isn't exactly the way you want it to be, we can go back in and see exactly what's happening. So the agents are all reporting and doing their work. So now if we go back, I'll go to this particular one. It takes half an hour to run to do all of this work. So we're not going to go to the complete end of it, but I have one, like a baking show here. I'm going to pull out the finished one from the end here. Let me start a new chat so we can start from the beginning. But one of the other things that we've done is this is also a very flexible user interface. So you see these tabs across the top, those are the results of all the agents. So each agent is putting out results and saying, like, we're going to summarize the protocol. This is an important piece of, like when you give this, like one of our partners, one of our investors is the Mayo Clinic. The Mayo Clinic says, when we do a study, we have to give information out of that protocol to all of these different places, to the pharmacy, to the study coordinators, the coverage analysis, contracts, budget. And so what we do is we extract the data and we say, okay, this is the data that goes to each place. And based on all of this information that comes out of this, we can also do things, we can pull up, again, because we're using knowledge base and some of the things that are inside of it, we can pull up the references to these things. And so here, in just a second after it loads, it'll go to this reference. Oh, I think it's behind the, there it is. So we can pull out all the references in the documents. Again, because accuracy and precision are very important to us, we foot every single thing. We can open it up in the documents so that the people that are using our platform can see it, they can understand it, they can understand and make these decisions along the way. We can go through, we can extract, let me close this. We can extract all the information about the timelines, we extract all the information about the budget. This type of work, like for example, this screen right here, this is literally weeks worth of work for people. To go through and understand exactly what's happening in the clinical trial protocol. What does the lab manual say you do? And did the budget actually say you were going to pay for that or not? And it's funny, they talk about these clinical trials. The very first thing you do in a clinical trial is an amendment to cover the budget problem you just found on day one. And we're trying to stop those types of things. And so this is weeks worth of work where you can go through and say, well, I want to look at the gaps between, and what is the gap, what happened, we describe it, we give people the exact information they need so that they can do those things. Really a powerful thing. And then another thing that's really important is we put together this multi-agreement chat capability where I can go in and say, what are the documents available? What tools do I have? And what analysis results do I have? Because all these analysis results, we're also feeding those back into the chat agent and back into the other agents. So when you're working in this chat interface, because sometimes people want to have a free-form ability to work with the data, we have to make sure and bring all of that data back into the system. So, we built this all on Agent Core. We use the memory, we use the sessions, we use all these things. Again, I don't have enough time to go through all of it, but it's a really powerful thing. So if anybody has any questions, we can go through those.
Any questions for Phil?
So, how does it handle the PHIs?
It's a good question. One of the nice things about what we're doing is in the clinical documentation, there is no PHI. So you don't put PHI into the protocol or into the budget or those type of things. So we're not dealing with actual clinical data, we're dealing with administrative data. So we tell everybody at the very beginning, never ever put PHI into the system. We even have guardrails that if we start to see it, we're like, please, we stop. We say, don't put PHI in our system.
Yeah, who are your users? Pharmas, FDA, or site runners?
Yeah, so it's the sponsors and the sites. So sponsors like the big pharma and also the clinical trial sites. We actually do both sides of the negotiation and both sides of the health. Again, we keep it really nicely firewalled off so that people can't see other people's data. But again, these people are coordinating. They're trying to get to the end. And so we put them both into the same system so that they can get to the end together.
Did you have to fine-tune models?
Frontier models?
Fine-tune.
Well, fine-tune the models. No, we do not fine-tune the models. We spent a lot of time looking at fine-tuning to get this. And what we found is the accuracy tends to come from a very structured workflow through the agents and very structured outputs and evaluators and those types of things. So some of these, like we'll have an evaluator that go back and look at these things. And that tends to be more effective than fine-tuning for us.
So it's basically prompt engineering, right?
Prompt engineering, but I would say it's even one step more than that. It's the entire system engineering, the entire structure engineering. Because when you have multiple agents doing multiple things and they're feeding back on each other, sure, the prompts tell the agent what to do. You've got to build it in the context of the much larger system. And so it's prompt engineering plus system engineering. And the system engineering is the hard part, frankly.
Any other questions for Phil?
You mentioned evaluators. How are you doing that? How do you have that set up, and how do you ensure accuracy of those evaluators as well?
Yeah, so most of our agents, most of our big agent workflows also have an evaluator component associated with them, where we have evaluation agents that have this access to the same documents and the results, and then we basically have those evaluator agents double check every single line in these, like when you see these things, we have our evaluators agents go in and double check every single one of these lines, and if it sees a discrepancy, it feeds it back into the system and says, let's do it again, and let's improve it. And we also use the session memory that was talked about earlier, so that we can remember those things. Now the user doesn't have to tell it to remember. The long-term session memory remembers those things. And so that it's self-improving in that sense.
Cool.
What's that?
Any specific framework that you're using for the evaluation?
No specific framework. That's custom developed. We built the framework specifically for these. Each workflow has its own framework for evaluation.
Well, let's give Phil a round of applause. Well, once again, thanks everyone for venturing out in the bad weather. Definitely appreciate you coming. And thanks for all the startups demoing tonight. For anyone that's interested, we have this QR code. If you feel comfortable leaving a feedback on the event, it's a little survey, and you get $25 in AWS credits. Good or bad feedback, but obviously we would like good feedback. The folks from Grafana have a bunch of swag up there to give away. Our next event is March 10th. If anyone's signed up for this event, we'll send out a message for the link to that once it's up. But once again, I definitely appreciate everyone coming. There's probably about a half hour left to keep networking Any final words?
Please eat pizza. We don't want to bring it back home.
Yeah, so this food, drinks, whatever, feel free to network, and there's a handful of us, Sean and myself, and a handful of other folks from AWS here. If you have questions, come find us. We'll have badges that look something like this. All right, cool. Thanks, everyone.